Hi guys, welcome to my video. Today I want to talk a little bit more about concentrations, solutions, and dilutions, and add in another concept that I want to do a little bit more practice on. So in our previous talk, we mentioned molarity, which is basically just a way of describing how much of a substance, a chemical, is dissolved in a solution. So we'll take the moles of our solute and divide that by liters of solution, and this will tell us how concentrated the solution is. But there's a second way to describe concentration, and it's not really used as much as molarity, but it's still really important to understand. And this is known as molality. So notice that this is also a lowercase m rather than uppercase m like we see for molarity. So molality is similar because it also has moles of solute, but this is actually divided by kilograms of solvent. So it's a little bit tricky to convert between molarity and molality because you have to figure out how much of the solution is actually just the solvent. So I want to go through a practice problem where we're going to convert in between these two, and I'm going to show you guys how you can calculate that. So this is our question. We want to convert molality to molarity. So the molality of a solution is 0.396 molality, with the molecular weight of the solute is 198.62 grams per mole, and the density of the solution is 1.14 grams per milliliter. So we can start off by saying that we have 0.396 molal of our solution, which is basically 0.396 moles per 1 kilogram of solvent. So what we have to think about is basically how much of our solvent will make up the solution if we convert to molarity. So the thing to remember, like we showed in the previous slide, the molarity is moles per liter of solution. So if we want to know how much the total solution is, like we said before, the solution is the solute plus the solvent. So if we know how much solvent there is, we can say, there's 1 kilogram. And this is just basically making an assumption. So because dividing by 1 is basically just 1, so we can just say that there's 1 kilogram of solvent. So don't worry about trying to figure out how much solvent there is. If we just assume, 1 kilogram total, this will give us the 0.96 moles as well. So hopefully that makes sense. So really what we're being asked to figure out here is, what is this mass of our solute? But then we eventually need to figure out what the volume of this solution is. So that's where the density will be really helpful, because we can convert from mass to volume. So the first thing that we want to do is actually figure out how much of the solute is composing the solution. So we can basically convert from moles to grams. So if we take 0.396 moles, and we're going to multiply this by our molecular weight. So we have 198.62 grams per mole. So moles will cancel out, and then we can calculate what the mass of that solute would be. So this is 78.65 grams. So if we wanted to add this to our total mass for our solution, we can just assume 1,000 grams, which is 1 kilogram, from our solvent. So our total solution mass would be 1,078.65 grams. And we want to actually convert from grams to milliliters, which this was where we can use the density. So if we multiply our mass of solution, we actually want to flip the density over, like basically invert it. So we're technically dividing here. So we can take our 1.14 grams, and this is because we want grams to be canceled out. So we're going to put grams on the bottom, and then this will give us milliliters. So if we divide our total mass by the density, we should get 946.18 milliliters of solution. So then we just want to go from milliliters to liters. So by dividing by 1,000 milliliters, this will give us our amount of volume in liters. So this will be 0.94618 liters. And then the last step that we have to do is just divide the same number of moles that we had in our molality by our new volume. So we'll take 0.396 moles divided by 0.94618 liters. And this should give us 0.4185 molarity. So if we want to pay attention to significant figures, technically we would have 3 significant figures based off of the original molality. So we can round this to 0.419 molar. So we successfully went from molality to molarity, but now we're going to try going the opposite way. So we're starting off with a solution that is given the concentration in molarity, and then we're going to convert back to molality. So if we start off with our original solution, one thing that you can do is just to assume, so if you're starting off with molality, so one thing you can assume if you're starting off with molality, you can assume 1 kilogram of solution, or basically of, solvent, because that will allow you to do the calculation. And the same thing with molarity, just go ahead and assume 1 liter of solution. So that's basically what we did in the first problem. That way we can just kind of use the whole numbers and go along with what the given values are more easily, rather than assuming more of like a tricky value that then you have to do more math. So if we go ahead and assume 1 liter of solution, that means that we have 3.53 moles per 1 liter of solution. And if we want to figure out what the molality is, we have to remember that this is moles of solute per kilogram of solvent. So what we really need to do is we have to take our solution and we have to determine how much of that is solute and how much of it is solvent. And that way we can subtract the amount of solute to figure out the solvent in order to figure out our molality. So the first thing that we can do is figure out how much solute we have. So if we take our 3.53 moles of solute and then multiply this by the molar weight, so this gives us 495.78 grams. So then we have our amount of solution, but this is in volume. So we want to convert the volume of our solution to grams, since right now we have our solute in grams. So if we take that 1 liter, we know that 1 liter is equal to 1,000 milliliters. So 1,000 milliliters. And then if we want to go from volume to mass, that's where the density comes in. So we can multiply by the density, and this gives us 1,180 grams of solution. So, like we said before, this would be the amount of solute and the amount of solvent. So if we want to know how much solvent there is, we can subtract the amount of solute that we just calculated to figure out how much solvent would be left. So if we do 1180 minus 495, this gives us 684.21 grams. Then the only thing we have left to do is basically convert this to kilograms. So this would be our kilograms of solvent, which is all we need left to figure out what our molality is. So if we just take that same number of moles that we started off with, divided by the amount of solvent, this should give us our molality. So once we calculate this, this gives us 5.159 molal. So there you go, pretty simple. You basically just have to remember separating out the solute and the solvent and using the density in order to convert between grams and milliliters. All right, guys, hopefully that helps. I encourage you to go back and maybe try these again a second time, but pause the video with the question, work through it, and then check if you get the same answer at the end. But I really hope this helped you guys. Don't forget to like, comment, and subscribe. And if you have other videos or topics that you want to suggest or request, you can go ahead and drop me a comment and I'll try to help you guys out with that. All right, cool. Have fun doing chemistry. Good luck studying, and I'll talk to you guys later.